In this tutorial, I'm going to briefly cover UI widget blueprints and how they differ from logic blueprints, and then go through an example of outputting dynamic values to the HUD. I'm going to be working with Mirror's Edge Catalyst as usual for this, but I imagine a lot of the concepts are the same for other games Frosty supports. First of all, UI elements are defined in UI widget blueprint assets. You can find them easily by searching for type UI widget blueprint. I'm going to open the HUD screen root widget. You might remember this asset from my first editor tutorial where we made the crosshair color green and made it bigger. So this looks a lot like logic blueprints we've seen before. It even has objects and property connections. Just like those blueprints did, though objects here are called components instead. However, if you look at these components, there doesn't seem to be anything that looks like UI elements or anything that would display something on the screen here, except maybe these print debug text entities. You probably will have noticed though that the other properties in this asset are quite different from the logic blueprints we've seen before. We have a bunch of different size properties like height and width that we haven't seen before. The important thing is this layers section. UI widget blueprints have layers, and layers contain elements, and those are what are actually displayed on the screen. As you can see, we only have one layer in here, and it contains a couple of circle elements which make up the crosshair, as well as references to other widgets such as the combat reticle and the compass widget and an input listener as well. Like with logic blueprint objects, there's a lot of different types of UI elements available, and I'm not going to describe all of them in this video. Just like with objects, you can search for them by clicking the three dots on an asset, clicking create new, and it'll open this picker here for you, and you can also obviously look through an XML dump for examples of what's available. The cool thing is that these UI objects work a lot like the objects in logic blueprints, meaning that they can have property connections hooked up to them to make them dynamic. The only thing that's different is that they have to exist in these layer elements rather than in the components down here. So let's jump into an example to get familiar with how this works, shall we? I mentioned in a previous video that we could use the HUD to display useful values to help us debug logic mods. So let's do that. Often you might need to know your coordinates in the game world, so let's try to display that on the HUD. I'm going to stay in this HUD screen root asset. In fact, the reason I picked it to begin with is because it's used for exactly this kind of mod, as it's basically always active. First things first, we're going to need to add some text to the HUD. That's pretty simple. We're going to first add a new element, and we want this to be a text field entity. And we can open that up. There's a fair few properties in here, but let's just try to get the bare minimum working for starters. We're obviously going to want this to be visible, so let's tick that. Likewise, alpha should be 1. Alpha is basically another word for opacity, and we'll put some placeholder text in here. That's us mostly ready to go. I want to do a couple more things first though. I want this text to be white with a black outline so it's nice and easy to read. And I want it to be in a nice font too. To set the font, we need to assign a font to this font style property. If you search for font, you'll find this font styles folder, and you guessed it, has a bunch of font styles in it. I'm going to go with this large white font style for now, and you apply it simply by clicking on it in the Data Explorer and then clicking the little arrow in the blueprint. We actually also need to set the color in order for this to actually be white. This is just an RGB value where the values are between 1 and 0. So this will just be 1, 1, 1. Lastly, let's add that black outline. There's no actual property in here for outline or stroke or anything like that, but we can add it using a font effect. In this font effects folder, you'll see that there is an outline effect. And we can apply that in the same way that we did for the font. So that's about us ready to go now. Now you may be thinking, but Pete, what about this size and this width and height properties? Don't we need to set those? Aren't those important? Actually, in the case of text fields, not really. The size property is mostly used for layout purposes, and the width and height are mostly used for shapes like rectangles and stuff like that. See more of that later. So let's launch the game for now and see how this looks so far. So as you can see, we now have our placeholder text in the top left of the screen, and it's white with a black outline. Let's move that text to somewhere different. And that's fairly simple. At the top you can see we have these offset, anchor, position, and expansion properties. You can also see that we have this layout mode, which is anchor offset, the other layout mode being position expansion. So that tells us which of these properties are being used. Anchor and offset seems to be the most common, and it's fairly straightforward. The anchor is a relative position on the screen to anchor the element. A value of 0 for x means it's anchored at the left side of the screen. 1 means the right side of the screen. 0.5 means the center, and so on. The same applies for y, but obviously for screen height rather than width. Right now it's 0, 0, which means top left. Let's change it to 0.51 to put it in the bottom center of the screen. I don't want it actually right at the bottom of the screen though, so we can offset it slightly using the offset property. The offset values are in pixels, and a positive x value offsets to the right and a negative to the left. A positive y value offsets to the bottom and negative to the top. So let's add a y offset of negative 50 to bring it up from the bottom just a little. We're also going to want to change the text alignment to be centered too. Otherwise, essentially you'll have the left edge of the text in the center of the screen and the rest of it to the right, which is not what we want. So we need to change the horizontal alignment to center. And I guess I might as well do the vertical alignment too, why not? Nice, now let's see how that looks in game now. Okay, nice, that's looking a lot better now. Now let's have a go at displaying our coordinates, shall we? For this, we're going to have to take the player position from somewhere, convert it to a string, and then input that into our text field. Fortunately, there's an easy way to get the player's current position already. There is a player transform schematic channel, and its sole purpose is to make the player transform available. So we need to add a schematic channel entity to our blueprint to use this. And this will go in the components rather than the elements section. So we assign the channel by selecting it in the Data Explorer and clicking the little arrow in here. And we need to check the realm is correct. It says client and server, so this should also be client and server. And then we need to add our output property, which actually can stay at 0. There's only one property in there, so it will have an index of 0. Now we have to do a little bit more work before we can hook this up to the text field though. If we look at a transform in an XML file, you can see that they have these right, up, forward, and trans properties. Right, up, and forward are unit vectors which describe the rotation of the transform, and trans I think is short for translation, which is the actual position. So we need to extract just that from the transform. Fortunately, there's a handy object for that, the transform splitter. This takes a transform input and splits it into each of those properties I just mentioned. So now we can add a property connection from our schematic channel, this one, and the source field ID on that is player transform. Then we hook that up to the transform splitter entity, which is this one. And the target field for this is transform. And I'm just going to go with flags of 2 as usual. Then we can start setting up a property connection which uses the transform splitter as its source. And the field ID that we want for that is trans, which was the name of the field inside of the transform that we wanted. However, that still leaves us with a translation, which is essentially a vector 3, and we need a string to pass into the text field. The type is important. So we're going to need to split up that translation into its x, y, and z parts, and then combine those numbers into a string. So let's start by splitting the translation, which is a 3 property vector, so we can use a vec3 splitter. So now we can complete this property connection from our transform splitter and put it into our vector3 splitter, and the input property for that is simply called in. Then we can prepare our x, y, and z outputs by putting the source as the vector3 for each of them, and the source fields will be x, y, and z. So the next step is to combine these into a string. To do that, I'm going to use what's called a checked localized string entity. Localized strings are pretty much what they say they are, strings which are localized into different languages so that the appropriate string can be displayed for your language of the game. Every localized string has an ID which you need to use it. I actually have a spreadsheet which I will link, which has a large number of known string IDs in it. But the cool thing about localized strings is they support string interpolation, which is a concept you may be familiar with from other programming languages if you have a programming background. Essentially, it allows you to substitute variables into a string dynamically, and that's why they're useful here. For example, if I enter id underscore cas underscore exp and then tab out of that, you can see it shows us this localized string, which you can probably figure out is used for displaying an amount of experience points that you have. This 0:d in the curly braces is a variable which can be substituted. The 0 is the index of the variable. If there was more than one variable, they would have different indices. The D is the type of the variable and can also specify some formatting too. In this case, D means integer. Fortunately, we don't need to hope that there is an existing localized string for the string we want to make. We can simply leave the SID blank and type our own into the debug string property. So we're going to need to display 3 variables, and they're going to be floats. To specify a float, you use the letter F. So we're going to simply write 0:f and then do the same for our other 2 floats. We can also specify how many decimal places we want to display by simply adding a dot after the f and a number. So I'm going to go with 2 decimal places. And I'll update these 2 as well. I'm also going to put a couple of slashes in between each of these, just so that it's easier to tell them apart once we're in game. Now we need to define our variables that we're going to pass in. To do that, we add arguments. So I'm going to add 3 of these. And here we simply define the types of the arguments. So these are all going to be floats. And then we add the argument hashes. For these, you simply type in what you want to use for the property connection field IDs. And Frosty will automatically hash these for you. I'm just going to go with X, Y, and Z for the sake of simplicity. Now we can finish hooking up our property connections from the vec3 splitter into our localized string entity. So I'm just going to set the localized string entity as the target object for each of these. And the target fields I have made the same, so they're all X, Y, and Z, so that's very nice. So finally, we can hook up the output of that localized string to the text field. So for that, our source is obviously going to be our checked localized string. Our target is going to be the text field entity, there it is. And the source field ID on the localized string is simply localized string. But we can't hook that up to the text property we used earlier for the text field. The text property accepts a string, which is technically different from a localized string. Fortunately, the text field also has a localized text property, which is intended for localized strings. So I'm going to get rid of that, and then we just need to add a connection to the localized text property of the text field entity. Now we're almost ready to go. We just need to check all of our flags. I've been setting the property connection flags to 2 as we go, as that usually works. Spoiler alert, I already know it will, as this is a pre-prepared example. We also need to check that our object flags are right. I'm going to use my tool for this again, which I will link as usual. So let's start with this schematic channel. This is only a source and doesn't have any links, so we don't actually need to set any flags on it. The transform splitter is a client and server property target because of the property from the schematic channel, so it needs those settings. So we copy this back into here. The vector3 is a client property target, so we need to set that. The localized string is the same, so we need to also set that. And finally, we can't forget about the text field, which is also a client property connection target, so we get the same treatment there. So we're good to go now. Let's check it out in game. Okay, that's looking pretty good actually. It's updating as we move around, as you would expect, though I think we could make it a little easier to read by adding a background, don't you think? Adding a background should be pretty simple. We basically just need to add a rectangle behind the text. So let's do that. I'm going to right click on this text field element and select insert before so that it appears behind it. Then I'm going to create a new rectangle. I'm going to turn on visible and set the alpha to 1 to make it completely opaque. I'm going to leave the color as it is because I want it to have a black background, which it already is, but I also need to enable the fill option to fill the rectangle with the color. Next, I'll set the positioning to match what we had for the text field, which is 0.51 and -50 the offset. For this element, I do need to set a width and height, and those are in pixels. I'm just going to go with 300 by 50 for now, just to see how it looks, but I know I'm going to change these later. And we also need to set the size to be at least as big. So I'm just going to make them the same for now. So let's see how that looks in game now, just so that we know what we've done so far works. Okay, that's not too bad. Obviously the alignment is a little bit off. That should be fairly simple to fix. Really, we want the width to be dynamic, as these values could get larger or smaller depending on where we are. And then the background will either be too big or too small. The height and vertical alignment I'll just fix manually, since that won't ever change. So I'll reduce the height to 40, I think, and I'll reduce the offset to -25. I think that'll do it. So let's make the width of this background dynamic then. To do that, we can simply take the width property of the text field and connect it to the width property of the rectangle using a property connection. Simple as that. So we just add our property connection. Source is the text field. Target is the rectangle. Fields are both width. Flags are 2. There's actually one more thing we need to do. In our text field, we need to enable auto adjust width. We should also actually increase the size of our rectangle in order to give it room to expand into. Note that this is different from the width. The width is more like the rendered width of the rectangle, whereas the size is more of a layout container for the element. So I'll just make this as wide as the screen, which is 1920 pixels. I also now need to update this rectangle's flags, as it is a property connection target. And now we should be good to go. Let's boot up the game and take a look. Okay, so that's looking a little better. Our vertical offset's a little bit off still. You can fix that. But the width is exactly right. And as I go far enough this way, you can see, there we go, it's changing correctly when I go from 1,000 to less than 1,000. We could use a little bit of padding though on the left and right, as well as fixing that vertical offset. So let's do that. Now we could use some logic to add a little bit of extra width to the edges before putting it into the rectangle. But there's actually an easier way in this case. All we need to do is add some padding to the auto adjust width on the left and right to give it a little bit of extra width. So let's go with 10 pixels on each side. And I'll fix that vertical offset while we're here. Let's make it 30. I think that'll be good. So let's check this out again. So there we have it, a pretty clean looking readout of our current position in the game world that updates in real time. Hopefully this was useful. I'll obviously upload my project file for this in case you want to download it and go through it in your own time. The link will be below. Thanks for watching.